Welcome back. This is Tom, and this is Tom's Radio Room Show. And I hope you're having a great day. You know, one of the traits of getting old is you have good days and bad days. And today I'm having a good day, and I look forward to those good days. So I hope you're having a good day. Today we're going to look at my array of USB testers and USB battery packs. Now, I've reviewed these two guys, the little guy here and the solar pack. I don't think I've reviewed this big one. But today I'm going to talk about a new test device I got yesterday. And that's this little guy right here. Now, what I used when I tested the solar battery pack was I used this static, I'll call it, load. And you can switch it between a 1 amp load and a 2 amp load. And I tested this solar pack here. And as one person pointed out, this is, let me set that down. This is a LiPo, that's what they call it, polymer battery pack. And this type of battery pack you do not want, or battery, you do not want to drain it all the way down to zero, because bad things happen, and especially the fact that it won't work after that. So there's circuitry in here to protect it, and so it will only go down to a certain voltage level, and then it'll shut that circuitry, will shut it off to protect it. So that's what I was seeing when I was doing my testing, where it got down to 1 bar here, which is an indication of what the remaining power is in this device, and then it shut off after that. So that may explain why the advertised capacity of 4 amp hours or 4,000 milliamp hours was not achieved. Matter of fact, I only got like 200, and let me see, I got my piece of paper that I wadded up here. I tested this a second time to see if it was a fluke, and once again it only got 2,536 or 2.5 amp hours capacity when I charged it. That's what's indicating what the charge was. And my discharge test only gave me 1.4 amp hours. And the person was explaining to me that was probably because of the circuitry that's built in here, this thing to protect it, shut the thing down before all of the capacity that I put in it was used up. So, but it's still, you have to be careful of when you're looking at these things about the advertised capacity. Again, this is advertised at 4 amp hours or 4,000 milliamp hours. I only got, when I tested it, I only got 1.4. So it's quite a bit less. Now, what other thing is that's kind of unusual is this little guy. Now this is made by Duracell. Let me see if it says, oh boy, I can't. Now this has a lithium ion battery in it, and its capacity is 1,000 milliamp hours. And I believe, I have to go back to my videos, I think I got about 800, not 1,000, which is not bad, you know, that's like 80%, where this, I got less than 50% out of it. So yeah, it's just some facts. Now this big baby is advertised at 10,000. And does it say? It does not say what type of battery it is. I have to go look that up again. But anyway, this big thing, not big, it's in a palm of your hand, is rated at 10,000. So I haven't really done a definitive test on this. So now that I got this little new device, and that's what I wanted to talk about, and then I got sidetracked on, well, anyway, this little device hopefully will do a little better job than this static load. Now, the reason I say that is because I don't know what I'm talking about, number one. So take everything I say with a grain of salt. But this appears to have a constant load circuitry, so that the load that this thing is putting on the device you're testing it is constant, which is much better when you're trying to get an idea of the capacity of these devices, where this guy is just a resistor and an LED. That's all it's on, and a switch. That's all it's on here. So as the voltage goes down on your device, then the amount of current that's being drawn through this resistor is going to be less. And what you really want to simulate a real device like your cell phone is you want a load that's constant no matter what the voltage is. So hopefully this will do that. Now I didn't take this thing apart, and I'm hesitant to take it apart because I tend to break things when I take them apart. So I don't want to break it because I want to use it. But looking down inside here, it looks like there is a 3-pin integrated circuit like device, which probably maybe be a voltage regulator, which there's a real simple circuit to make a constant load device, and that's using a voltage regulator. And there's a couple resistors, and that's about all I can see. Maybe some capacitors or something. And then there's this variable resistor right here, and that sets the load. You can set the load by turning that. You can set this load from 0.33 amps, which is what I want. I want something less than a half an amp, up to either 2 or 4 amps. I don't remember. And it's got this big heat sink, and it has this little tiny fan for cooling the thing. Now, I did a quick test of this device because I had it charged already using this load, and I set it to the minimum. I set it to 0.33 amps load, and all through the test, that current, and when I say load, I'm talking about current in this case, that current stayed the same throughout the whole test. And this heatsink just barely got warm. I mean, it felt like maybe 100 degrees at max, just above body temperature. And the fan never come on, so I'm thinking the fan is thermal controlled, and it only comes on when it needs to. So that's cool too. So anyway, the plans now that I have this new handy dandy device, and I got this off of Amazon. It was about $9, $8.98 or something like that, with free shipping. And like I say, I did do one short test with this guy. The results of the test were, let's see, I have them right here, is that I didn't. Oh, wrong page. Okay, wrong piece of paper. I was going to say the results were it only had 38 milliamp hours. No, that was the wrong page. Okay, the results were for that particular test, and this had been charged about a month ago, so I didn't recharge it. So I don't know how much. That's another test I want to do, is the shelf life test. Once you charge these guys, how fast they discharge themselves when they're sitting on the shelf or on the floor or wherever, in your bathtub, wherever. So anyway, this wasn't necessarily fully charged, and using this as a load with 0.33 amps, it had a capacity of 670 milliamp hours. Now, The one problem I have is I need to get a drink. I'm sorry. The weather conditions are changing here in Florida, and my sinuses are going crazy. One thing about this setup is, since this tester, and this is the tester I'm using, which gives you voltage, current, and wattage, and capacity. And this has been recharging now for several hours, and it's showing the capacity has built up to 1131 milliamp hours, and this is only rated for 1,000. So it's, and I noticed that the current now is dropped way down to 0.14 amps. So it's about fully charged, and theoretically, and it doesn't show up very well, but theoretically, when it's fully charged, this orange light is supposed to change or go off. I don't remember which. So it's probably pretty close to being charged, and then I can do my test. But what I was getting ready to say is, my testing is not what you call very scientific. So I was just periodically coming in here and checking the reading, because what happens since I'm using this device to measure the capacity being drawn out of this battery pack, once the battery pack, and the battery pack is, in that test, the battery pack is supplying power to this device. Once the voltage gets down to a certain level, the tester goes off and you lose the reading. So I may have gotten a little higher reading than 670, because that last check I made was at 11:39 a.m. and at 2:09 I came in here and it was off. So I lost about 20 minutes there of capacity. So this might have gone up a little higher. And what I'm going to do is, I have what's called a wildlife camera. It's a camera that you put out on a tree or something, and it captures pictures of wildlife. And the way it works is, it takes a snapshot at whatever interval you set it at. So you can say, okay, take a snapshot every 5 seconds or 2 minutes or whatever. And I can use that for this test and keep taking a snapshot of this guy, say every 2 minutes or 3 minutes, and then I'll record in that camera the reading just before it goes off. That's what I'm going to try anyway. I don't know if the camera, because the camera again it's a wildlife camera, so it's for shooting outside with lots of light, and it has a minimum focus, I think, of 3 feet. So I may have a problem in that I can't get it close enough and be in focus to read this. So that may not work. Another method I can use, which is a little more tedious, is I can use this timer and set it to initially set it to 30 minutes, and then after a couple hours set it to 10 minutes, and every 10 minutes come in, write the reading down. Like I say, not very scientific. If you got any ideas, I'm welcome to any ideas. So anyway, so that's what we're going to do now that we got this little handy dandy device. Again, I got this off of Amazon for $9, and I think, it came with nothing as far as instructions or schematic or nothing. And of course, it's pretty straightforward. You just tweak this knob here and sets the load and plug it in. There you go. But I'm thinking, just looking down at the inside this thing at the components, I think it is attempting to be a constant load device, which is what I want. So we'll be testing this guy. He'll be charged up here pretty soon. Then we'll test the big boy after I've recharged him, and then we'll test this again with this load instead of this load, and see how they do, and I'll give you a report of all the results. I won't be shooting any videos as far as the testing is going, because you know, not much to look at, and it takes quite a while. It takes, for instance, this guy takes about 6 hours at least to fully charge it after it's been discharged as far as it'll go down, using the USB port. And again, it's raining again, overcast, so I still can't test the solar panel. But what I've read, it can take 3 to 4 days of full sunlight to charge this thing using the solar panel. Now, granted, and like I say, this is rated at 4 amp hours, and it wasn't very expensive. Now, these can go up really high in price, up to $100 for about the same capacity. But I assume they have better solar cells, or a different type of solar cells. And this guy was about $14, I think. And like I said before, it's 10,000 milliamp hours rated at that. So we'll see. So anyway, that's kind of what I'm doing. And I hope you enjoyed the show. If you did, please give me a thumbs up. I plan on doing some other testing. Like I say, I plan on doing a shelf life test. Now, I don't know how long I'll run that test. You know, maybe 60 days. Maybe I'll do 60 days and I'll check the output voltage. That's the only thing I can really check without draining it. Is and maybe at once a week or something like that, and chart all 3 of these guys and see how they hold the voltage. Unless you got some other ideas, you know, because I don't want to drain it, because then I have to start test all over. So about all I can do is just check the voltage. Again, these are all 5-volt outputs for charging your USB devices. I really, believe it or not, I really like this guy. This guy's really, really handy. Not much capacity. If you go back to my video where I tested it and I tried to use it to test my cell phone, basically all it did when my cell phone was, say, down to 30%, it charged at maybe 10%. Of course, that's not very accurate testing either, but it was probably enough that you could use a cell phone to make a call if you were in distress or just lonely. Anyway, that's the show for today. Yeah, give me a thumbs up. What the heck? And subscribe. Yeah, I think we're going to make 5,000 subscribers in the next couple of weeks. Could happen. Thanks for watching. Bye-bye.